Now in chemical reactions of alkene, first one is hydration. Hydration means adding water molecule. So when you add water molecule, we have to use H3PO4, 300 Celsius and 60 atm. So we are getting alcohol, ethanol. Hydrogenation means adding hydrogen. So in that case, we have to use H2 and nickel and we have to heat it, right? So you are getting alkane, okay? Alkane, right? Third one, we can do bromination or any halogenation, okay? Bromination, adding bromine. So same thing happened, children. So when you add bromine here, what happened? The double bond is broken. And this reaction occurs at room temperature. So you'll be getting this sort of dibromoethane. Okay, dibromoethane. Next one, we can add hydrogen halides, right? Adding hydrogen halides. Fourth one. Addition of hydrogen halides. Hydrogen halides. So whenever you add hydrogen halides, so get the alkene here and you can add HCl or HBr, whatever thing, children. So this reaction even occurs at room temperature. So hydrogen goes to one place and chlorine goes to the other place. That's what we call adding hydrogen halides. Right? And there's an important thing over here, children. When it comes to the symmetrical molecule, symmetrical means the molecule is actually above the double bond, it's symmetrical. But if it is asymmetrical, something like this, if I take this sort of molecule, like propane, CH double bond CH with HCl, what happened there? There are two possible things. One is major product, the other one is minor product. Major product means hydrogen is attached to the carbon with more hydrogen attached. That's what we call major product. So here what happened? CH3CH, hydrogen goes and attached to this place and Cl goes to this place. That's what we call major product. In minor product, what happened? Hydrogen goes to this place and Cl goes to this place. That's what we call minor product. I'll tell you how does it happen when it comes to the mechanism. Is that clear now, Ranitu? Itara? Okay. Itara, can you hear me?
Yes, sir.
That's called hydrogen, adding hydrogen halides. Remember the major product and minor product, right? Major product means hydrogen goes to the carbon atom with more hydrogen attached. That's what we call major product. Right. Fifth one, oxidation. in oxidation, we can use cold dilute KMnO4 or hot concentrated KMnO4. There are two reactions, right? First one, cold dilute KMnO4. Whenever we use it, the double bond in alkene is broken, right? Cold and dilute KMnO4, acidified KMnO4. Then what will happen? Two OH groups are attached to each carbon. So this sort of thing is called diol. Diol. A diol is produced. When it comes to hot concentrated KMnO4, the products depends on the type of the atoms attached to the molecule, right? Say for example, if the molecule is having two hydrogen atoms, it can produce carbon dioxide. I just ignore these two. These two groups can vary. The other one, if the double bonded carbon atom is having one hydrogen with alkyl group, first it gives aldehyde, CH3COH. When you distill off this thing, then if you use reflux apparatus, you will be getting a carboxylic acid. Something like this. So just add C double bond over to the center carbon. That's what happened. Last one. If there are two alkyl groups are attached to the double bonded carbon, right? Then what happens? A ketone would produce CH3COCH3. Ketone would produce. These are the three products. Please remember that. Right? So the products depends on the types of the groups attached to the double bonded carbon. Okay, ne? Is that okay, Manitu?
Yes.
Yes.
All right. It's back again. Then there are three more children. Sixth one is cracking. So in cracking, we can divide cracking into two categories. One is catalytic cracking, the other one is thermal cracking. Cracking. So in cracking, what do? We take some long chain hydrocarbon alkane and we supply around 400 to 500 or 600 maybe temperature. And we can use alumina or a zeolite, SiO2 even fine. So you'll be getting an alkane and alkene, right? It's a mixture of alkane and alkene. So they will give you the compound where they cracked and the one of the product is given. So you should know how to get the rest of the product by subtracting. So cracking is important in order to make octane petrol. We can take octane, right? And also these products, they are having a greater demand. That's the most important, right? greater demand, okay? Because they are more energy efficient, can be burnt easily. Those are the important things. Right. Seventh one, polymerization. Polymerization. In polymerization, what happened? We have a double bonded molecule. It can be any groups attached to this thing, right? So when you apply high temperature and pressure, this small group is called monomer, right? So the molecule is broken, the double bond is broken, and these components are added continuously, right? So say this is 1 unit that can be added again and again, like this C6H5HH, like that. Then you should know what is the repeat unit, right? Repeat unit is the one which is repeated. Look, this part is repeated. So they may ask you to draw the repeat unit. So in that case, you have to draw this, right? H, C6H5, HH. Then repeat unit be times n. Now put the bracket and times n. That one. That's what we call polymerization, right? Now we can go through the reaction chart as well. Now all the reactions are given in the reaction chart. You can just have a look. You got this thing right, Itara? I've sent today right now, actually. I'm sorry for that. Okay?
Okay, sir.
Look at adding bromine, bromination. They all are called as electrophilic addition. Now, addition polymerization, H2 nickel catalyst heat, then adding HCl, adding HBr, oxidation, adding water hydration, last one oxidation. Whole dilute means diol. Now, everything done. Then we'll go through that asymmetrical thing. Now, when it comes to asymmetrical one, Br2 there is no problem. Double bond is broken. Bromine is attached to different thing. Whole dilute KMnO4 is diol. Hydration means again the same rule. H goes here, OH goes to the middle one. That's a major product. Again, polymerization can be done. H2 nickel heat, obviously double bond is broken. Then HBr, major and minor. Look, major product, hydrogen is attached to the last carbon. Minor is hydrogen is attached to the middle one. Then with hot concentrated KMnO4, that is what we call this oxidative cleavage, rupture in the molecule. So when there are two hydrogen atoms, it gives carbon dioxide. When there is one hydrogen, it gives ketone. Sorry, aldehyde and carboxylic. Two alkyl groups, it gives ketone. Right. Hope you all are okay with the reactions now. Now we'll go through the reaction mechanism and see. Right. Now all the mechanisms are having the same actually same steps, right? We can find same steps, right? So just go through reaction mechanism, right? The topic, reaction mechanism. This reaction mechanism is called electrophilic addition now, because they make electrophiles. Okay, which is right. The mechanism is electrophilic addition. Electrophilic addition now. There, what happened? Right, so you take the alkene here, and after that you can put this HBr. HBr means polar or non-polar, children. Now you know that bromine is more electronegative than hydrogen, right? Yeah. So bromine can pull electrons towards it. So they are getting slightly negative charge here, bromine, and hydrogen gets slightly positive charge. Then this one breaks towards bromine. Other one, actually hydrogen hits on the double bond, but we put the arrow always from the higher electron density. Huh? So we put the arrow towards hydrogen. Pi bond is rich in electrons. Then what happened? First hydrogen will be attached to this carbon. Then since this double bond is broken, this carbon gets slightly positive charge. Actually not slightly, completely positive charge. Then what happened? The Br minus with lone pair of electron hit on this thing. Therefore, what happened? I write this thing as CA3. So bromine is attached to this place. So those are the important steps. Huh? You have to show the polarity delta minus delta plus and put the arrow from the double bond and towards Br also. Then Br minus with lone pair of electron hit on that carbon. Right. This is what we call electrophilic addition. Right. When it comes to bromine, bromine is having same Br, same electronegativity. That is non-polar. But remember, children, when this bromine molecule comes closer to the double bond, the polarity is induced. Because this double bond, pi bond is rich in electron, it seems to be like negatively charged. So this one gets slightly positive charge, this one gets slightly negative charge. Polarity is induced due to proximity of the double bond. When it reaches towards the double bond, polarity is induced. Then what happens? This thing breaks towards Br minus, and this one hits on this thing. Now first, bromine is attached. After that, positively charged Br minus with lone pair of electrons. Same procedure. Right. Now, both of them are attached here. That's bromination mechanism. Right. Now, when it comes to electrophiles, you have to think about, okay, positively charged substance may hit on the double bond, but we put the arrow from the double bond towards the positively charged species or the substance, right? Next one, when it comes to the asymmetrical one, like propane, Now I am going to explain about that major product and minor product, right? So as I said before, if I take propene, it's something like this. So you will be getting major product. If I add HBr, major product would be Br attached to the carbon atom with less hydrogen, and minor product would be the other way around. CH3, CH2, CH2Br. Now, in order to explain this major product and minor product, I'll take this intermediate carbocation. Intermediate carbocation means, children, just before Br minus hit on this thing. What's the intermediate here? CH3, CH, CH3. This one is positive. Then only Br minus tend to hit on this thing. That's the intermediate. If I take this one, CH3, CH2, CH2 positive. Now the stability means, children, stability depends on the charge of the carbocation. If the charge is less, they become more stable. Look at first one. There are two alkyl groups. Push. No? So this is what we call, children, secondary carbocation. But here we have only one alkyl group push. That is what we call, children, primary. Secondary carbocation is more stable than primary because there are two groups pushed. Since secondary carbocation is more stable than primary, this would be the major product. The other one would be the minor product. Is that clear now? So always it tend to make the secondary carbocation because it is stable. Think about the stability of the carbocation. Tara, okay?
Yes, sir.
Anitu?
Yes.
That's all about alkenes. Now we'll go through the tube. Some questions. Then we have alcohols and halogenoalkane. We can do it one day. Anyway, I'll try to